So question 1 here, we have single replacement reactions, and we want to indicate if the reaction will occur or not. So for a single replacement reaction, the lone element will replace the one in the compound. So magnesium will replace aluminum, zinc will replace copper. But this only works if the lone element is more reactive than the one in the compound. So if we look at silver and calcium, silver is less reactive than calcium. So it's not going to be able to replace it, and this would be no reaction. The next question, we're looking at magnesium and aluminum. So here's magnesium and here's aluminum. So since magnesium is more reactive than aluminum, the magnesium will replace the aluminum and instead will form magnesium phosphate, and then aluminum will be by itself. So this reaction does occur. The next reaction, we're looking at zinc and copper. So here's copper, and here is zinc. So because zinc is more reactive than copper, it'll replace it. So instead we'll form zinc sulfate, and then copper will be the lone element. In question 2, we have double replacement reactions. So for double replacement reactions, we need to switch the cations and then determine if anything is not aqueous. So if everything's aqueous, that means no reaction is going to occur. So looking at KCl and AgNO3. So potassium is going to have a +1 charge. Nitrate is a polyatomic ion here with a -1 charge. Silver is one of those exceptions that's always +1. And then lastly, we have chlorine, which is going to be -1. So once I identify all these charges, I'm going to switch the positive charges. So I'm going to get silver chloride and potassium nitrate. So now I have to check to see if either of those is not aqueous. So if it's a solid, a liquid, or a gas, it just needs to not be aqueous. So for that, we're going to need our solubility rules. So for halides, like silver chloride, those are usually soluble except when combined with silver. So that's going to be a precipitate. That's going to be a solid. The other thing we have is potassium nitrate. Nitrates are always soluble, so that one will be aqueous. So this is a solid, this is aqueous. So does this reaction occur? Yes. Okay, let's take a look at the next one. So we have ammonium, NH4, which is a polyatomic ion with a +1 charge. Nitrate is -1. Potassium is +1. And then this is KRO4, which is potassium chromate. So this CrO4 is chromate. And that has a -2 charge. So I'm going to switch my ammonium and my potassium. So I'm going to form instead potassium nitrate. We already said that's going to be aqueous. And then I'm going to have this ammonium chromate here. And since that charge is -2, I'm going to need 2 of these ammoniums. So looking at my solubility rules, ammonium compounds are always soluble with no exceptions. So that means this is going to be aqueous. So since both of those are aqueous, this reaction does not occur. Okay, next up we have strontium. Strontium is going to form a +2 charge. We also have the polyatomic ion hydroxide. And then we have sodium and sulfate. So here's sodium +1 charge, sulfate SO4 -2 charge. So I'm going to switch the strontium and the sodium. So I'm going to form sodium hydroxide here, and that's +1 and -1, so that works. And I'm also going to form SR, remember that's 2+, and sulfate is SO4 -2. So it's just SrSO4. So now I need to check the solubility rules, and I'm looking for strontium sulfate and sodium hydroxide. So sodium is a group 1 element, so that's going to be soluble. Sulfates are usually soluble unless you have strontium sulfate. Then you're going to make a solid. So this guy will be aqueous, this guy is solid, and since we form a solid here, this reaction does occur. Okay, what solid is formed when aqueous potassium iodide reacts with aqueous lead 2 nitrate? So potassium iodide, potassium is K, and iodide used to be iodine. So K is +1 and iodide is -1, so Ki is our formula. And it's going to react with lead 2 nitrate. So the lead has a +2 charge, nitrate has a -1 charge, therefore I need 2 of them to balance out my charges. So this is just another double replacement reaction, which means we're going to swap the cations here. So I'm going to form potassium nitrate. We've already established that that will be aqueous. Nitrates are always aqueous. And then we're going to form PBI. Now the charge on this lead is +2, and the charge on iodide is -1. So what you would need to type into this box, we need 2 iodides here. So you could just type in PBI2, and that would count as the correct answer. What is the net ionic equation when calcium chloride? So calcium is going to be +2 because it's in the second column on the periodic table, and chloride is -1. So I'm going to need 2 chlorines to balance out my charges. And this is reacting with aqueous sodium carbonate. So sodium is Na with a +1 charge. Carbonate is the polyatomic ion CO3 -2. So I'm going to need 2 sodiums to balance out that -2. Okay, so another double replacement reaction. We need to switch the sodium and the calcium. So that's going to give me sodium chloride, and those charges are +1 and -1, so those work. And we know that salt dissolves in water, so that's going to be aqueous. And then the other thing that we form here is calcium carbonate. Now calcium is +2 and carbonate is -2, so those charges balance out, so it's just CaCO3. So then looking at my solubility guidelines, carbonates are usually insoluble unless combined with group 1 or ammonium. So calcium is neither group 1 nor is it ammonium. So this is going to be my solid. So how do you type this into the box here? The net ionic equation is only the ions that actually react to form a solid. So what ions were involved in making this solid? So we had calcium +2 aqueous plus carbonate -2 aqueous, and this formed calcium carbonate solid. So how do you type this in here? So you can type Ca and put AQ, and then you can put a plus sign and type in CO3 and put an AQ, and then make an arrow, so you can just do like an equal sign if you prefer, and then CaCO3 solid. Now you have to show those states there. So we have to see aqueous and we have to see solid. Okay, now this one we're just predicting if these are aqueous or solid. So first one we have is barium sulfate. So sulfates are usually soluble unless combined with barium. So that's going to be solid. Silver phosphate. So phosphates are generally insoluble unless combined with group 1 or ammonium. Silver is not group 1 and it's not ammonium. So these are both going to be solids here. So in the next quiz, it was all about being able to write this equation here, balance it, and then answer some questions about it. So let's go ahead and write this out. We have aqueous iron 3 nitrate. So iron is Fe, and this Roman numeral is telling you that the charge on the iron is +3. Nitrate is a polyatomic ion, so we would just look that up on our chart here. Nitrate is NO3 with a -1 charge. So to balance out that +3, I'm going to need 3 of these. So that will give me -3 and iron gives me +3. And it says that this is aqueous. It's going to react with sodium phosphate. So sodium has a +1 charge because it's in the first column on the periodic table. And then phosphate is the polyatomic ion PO4 3-. So since PO4 has a -3 charge and sodium is only +1, I'm going to need 3 of those. And it says that this is aqueous. So we're going to form sodium nitrate. So that's going to be Na +1 charge, nitrate -1 charge. So those charges are already balanced, so there's sodium nitrate. And then we're also going to form iron 3 phosphate. So iron is +3, phosphate is -3, so those charges already balance out. So now we got to look at these products and figure out if one of them is a solid. So sodium nitrate, nitrates are always going to be aqueous, and phosphates are pretty much always going to be insoluble or solid unless combined with group 1 or ammonium. Iron isn't one of those. So this guy will be aqueous and this guy will be solid. So now our next step can be to balance this equation. So we can take inventory here. So we have 1 iron, 3 nitrates, 3 sodiums, 1 phosphate. On the other side, 1 iron, 1 nitrate, 1 sodium, 1 phosphate. So to make this balanced, I just need to put a 3 in front of this guy, and that'll give me my 3 nitrates and my 3 sodiums. Okay, so now that we have this balanced chemical equation, we can start answering some questions. So how many atoms of oxygen are in that iron 3 nitrate? So remember that we need to have 3 nitrates here because each of them is -1. So we've got nitrate, another nitrate, and a third nitrate. So that is a total of 9 oxygens. What is the coefficient on the iron 3 phosphate when you balance the equation? So if we look back at our equation, iron 3 phosphate, there's nothing in front of it, which means that it's just a 1. What was the coefficient on the sodium nitrate? So the sodium nitrate, we had to put that 3. The correct formula for sodium phosphate. So since sodium is +1 and phosphate is PO4 -3, I need 3 sodiums. So that's going to be choice C. And then the state of matter of the sodium nitrate, in our equation we found that to be aqueous.